One of today's most prominent and advanced physicists has expressed his opinion on the matter. Michio Kaku, recognized for his outstanding contribution to the fields of physics, has recently confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists thought could not exist. These investigations have the potential to open up new dimensions in our scientific understanding of the universe. It is therefore exciting and worth keeping an eye on these developments. Michio Kaku is an outstanding figure in the scientific field. A physicist of American and Japanese origin, he is considered an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the amazing result of the James Webb Space Telescope mission. We are delighted that this distinguished scientist has decided to break his silence and publicly share what can no longer be denied. The enthusiasm and almost amazement of the renowned stellar physicist is evident in his comments on the discovery made by the James Webb Space Telescope, expressing that this has been the highlight that has piqued his interest. Join us to discover the implications of Michio Kaku's discovery of these 6 massive galaxies. Michio Kaku is a scientist who has always been willing to consider new theories throughout his life. He is aware that Einstein's equations of relativity and Newton's law are insufficient to capture the full complexity of the universe. Michio Kaku, a renowned theoretical physicist and science communicator, has always maintained a forward-thinking perspective on the nature of the universe. With the advent of the James Webb Space Telescope, JWST, Kaku recognizes that we are standing at the threshold of a new scientific era, one that could reshape our fundamental understanding of cosmology, astrophysics, and the origin of everything we know. He understands, perhaps better than most, that the discoveries being made by this powerful new telescope are not mere refinements to existing theories, but represent groundbreaking revelations that could force the scientific community to rethink core assumptions that have stood for decades. Among the most compelling findings from the JWST are images and data suggesting the existence of massive galaxies that formed much earlier than previously thought possible, some within just a few hundred million years after the Big Bang. According to the standard cosmological model, this timeline is highly problematic. The early universe, immediately after the Big Bang, was believed to be a chaotic, hot soup of particles. It supposedly took hundreds of millions of years for matter to cool down enough to form stars, let alone complex, structured galaxies. Therefore, the presence of fully formed galaxies with more mass than the Milky Way in such an early epoch presents a serious challenge to the Big Bang theory, as it is currently understood. Kaku sees these revelations not as anomalies or data errors, but as an opportunity, an invitation for science to evolve. He is aware that scientific progress has historically occurred not through the blind defense of existing theories, but through the willingness to revise them in light of new evidence. Yet, many of his colleagues have been slow to adopt this perspective. While some cling tightly to established models, hoping that further scrutiny will reveal a mistake in measurement or analysis, Kaku remains open to the idea that our universe might be more complex, more ancient, or fundamentally different than we've imagined. This resistance to change is not unexpected. The scientific community, like any human institution, is not immune to cognitive bias and institutional inertia. Many cosmologists have invested their careers into developing and defending the Big Bang model. They have written volumes of academic literature, secured countless research grants, and built entire subfields based on the assumption that this model is essentially correct. For them, the notion that these pillars of understanding might be built on incomplete or flawed premises is understandably unsettling. Some scientists are reportedly experiencing what can only be described as professional anxiety, sleepless nights filled with uncertainty about whether their life's work will soon be overturned or rendered obsolete. Interestingly, this upheaval is not confined to traditional cosmologists. Even proponents and opponents of quantum mechanics, typically at odds with one another, find themselves equally rattled by the implications of JWST's findings. Quantum theorists who have tried to reconcile the Big Bang model with quantum fluctuations at the beginning of the universe now face new puzzles that don't easily fit into existing frameworks. For example, if these early galaxies really did form so quickly and so massively, then the quantum fluctuations believed to seed galaxy formation might require reconsideration. The mathematical models that predict slow, gradual galactic evolution from quantum seeds may no longer hold water. Likewise, those who oppose the quantum view must now contend with a universe that seems to defy deterministic, classical explanations. Yet in the face of this intellectual disarray, Michio Kaku remains characteristically calm, almost amused. He doesn't view this turmoil as a crisis, but as a natural and necessary part of scientific progress. Where others see chaos, he sees opportunity. Where others lie awake at night, anxious about what these revelations could mean for their theories, Kaku laughs, not in mockery, but in the joyful realization that we are on the verge of discovering something truly transformative. For Kaku, the discomfort of the scientific community is not a sign of failure, but a sign that we are asking the right questions. His reaction stems from a deep appreciation for the scientific method, which is not about dogma, but about discovery. Kaku often reminds audiences that many great theories were initially dismissed or ridiculed. The heliocentric model of the solar system, plate tectonics, and quantum theory itself all faced fierce resistance before becoming foundational truths. He argues that science must always remain flexible, rigorous, yes, but open to radical revision when evidence demands it. In Kaku's eyes, the discoveries made by the James Webb Space Telescope could very well be the 21st century equivalent of Galileo turning his telescope to the sky and discovering that Jupiter has moons or that Saturn has rings. Such observations shattered the comfortable view of a geocentric universe and ushered in the modern age of science. In much the same way, JWST may be shattering the long-standing belief in a singular beginning of time and a predictable, gradual cosmic evolution. What excites Kaku the most is the possibility that we are missing an entire chapter, or perhaps an entire volume, of cosmic history. If galaxies could form so soon after the Big Bang, perhaps there were other forces at play, or perhaps the universe is cyclic, having undergone previous epochs of expansion and collapse. Alternatively, the very metrics we use to estimate cosmic time and distance, such as redshift, might need reevaluation. Kaku knows these are radical ideas, but he embraces them because that is what good science demands. The courage to explore the unknown, even when it contradicts what we thought we knew. The James Webb Space Telescope has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The team of astronomers who may have made the discovery have dubbed these exceptional galaxies universe breakers, because if confirmed, they would revolutionize our entire understanding of the universe. Something doesn't fit here anymore. The Big Bang Theory tells us that the cosmos was a hot mess after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for the objects to reach sufficient density and produce light. The formation of complex structures such as galaxies was assumed to occur much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their immense luminosity indicates that they were probably forming hundreds of new stars each year, whereas our galaxy formed stars only sporadically. It remains uncertain exactly when the first galaxies formed. Researchers have not been able to determine this so far. The only thing that is clear is that initially, there may only have been single stars or groups of stars, which eventually joined together to form larger and larger accretions until dwarf galaxies developed. These small galaxies encountered other galaxies and gradually grew. According to previous theories, highly organized and massive galaxies could not have existed at that time, which raises the question of whether the universe is much older than previously believed or whether complex stellar or galactic arrangement developed much earlier. This circumstance is difficult to accept for conservative science, which still finds problems with this model, and some branches of physics vehemently refuse to accept this discovery and question possible errors in the age calculations. Michio Kaku was aware of this and had this to say. There are many examples of old and false theories that stubbornly persist because of the prestige of some scientists. Many of these theories were only discredited when a crucial experiment revealed their falsity. Therefore, The fundamental work in any science, especially in physics, rests within the experimentalists who keep the theorists honest. In fact, on Earth, we know very little about the true beginnings of the cosmos. The Big Bang Theory was established in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to conceive of a universe with a beginning and an end. The idea of a universe that had always existed and was infinite in time and space was beyond people's imagination. Even today, scientists still face difficulties in understanding it. However, it is important to consider these probabilities once again. These new demonstrations do not fit at all with what researchers have based for decades on the Big Bang Theory. However, science has shown time and time again that reevaluation and openness to new ideas are an integral part of the scientific process, as is the confirmation of certain theories and observations. When Einstein was a child, it was believed that the stars and planets were firmly fixed in the universe and that these particular structures occupied a defined space. However, we now know that everything in the cosmos is in motion. Planets orbit stars. Stars move within their galaxies at hundreds of kilometers per second. Entire galaxies move rapidly through the cosmos, the fate of which we cannot yet even predict. Today, scientists are challenged to accept uncomfortable truths and to understand that theories are not only guesses and not absolute truths until they are rigorously tested or confirmed by accurate observations. The idea of the Big Bang arose from the realization that galaxies are moving away from each other, and this distance is proportional to the distance to Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies and other cosmological structures seem to support this theory. However, it is important to remember that in the past, people who believed that the Earth was flat and that the sun revolved around us also had this confirmed evidence for their assumptions, until coincidence or technological improvements came along that provided a clearer and more accurate picture. Right now, we are witnessing a similar situation. Scientists expected the new JWST space telescope to confirm the assumptions related to the Big Bang, but instead, they have come across these 6 galaxies that seemed impossible. This reminds us that science is constantly evolving and that scientists must be open to new discoveries and rethink existing theories based on the available evidence. Researchers use redshift as a tool to determine certain quantities in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, you can imagine standing still and seeing a car coming towards you. As the car moves towards you, you hear the sound of the engine getting louder. However, once the car passes you or moves away from you, the sound of the engine changes. This is because the sound of the engine varies as the car moves. The same is true of light. When a light source, such as a distant star, moves around us, the light we perceive shifts towards bluer hues. On the other hand, when the light source moves away from us, the light shifts towards redder hues. This phenomenon is called redshift. Physicists have converted redshift values into velocities and distances for measurement in the study of the cosmos. However, it is important to note that small errors in these measurements could have significant effects. The measurement techniques previously used are currently under review, and it is interesting to see what results scientists will arrive at. As for the latest demonstrations related to our cosmos, it is necessary to consider whether they are really based on redshift errors or whether some scientists are simply denying the facts. This is a question that requires rigorous analysis and careful review of the data and methodologies used in the research. Thank you very much for watching the video. As always, we remind you that you can post your doubts in the comments box. If you liked the video, do not forget to hit the like button, share it so it reaches more people, and subscribe to the channel so you don't miss more content like this.